Okay, everybody, so we are back with section 10.2 and 10.2 part 2. And what we're going to talk about is basically how to use some of the information we had before to find the measures of different things. So in this case, in reference to the measure of circle F, we're looking for the measure of angle AED. And let's go ahead and find it. Angle AED is here. I said angle, I'm sorry, babies. The measure of arc AED. Well, since these two arcs are adjacent, and we know that this is 90 degrees here, we're going to add 90 and 63 and get the total arc measure. So 90 plus 63 is going to give us 153. So the measure, the arc measure of AED is 153 degrees. Continuing on, we're going to look for angle ADB. Let's find that ADB. I keep saying angle, babies, and you know I mean arc. You know I mean arc. It's kind of confusing because arc measures and angle measures are both done in degrees, and arc measures are so closely related to the central angle degree measure that you see why I'm making confused mistakes. So if I look over here, let's go ahead and take a look. I've got 63, 90, and then this bit here. And if you look carefully, you can see that BE is a diameter, and therefore this arc EB is 180 degrees. So basically ADB would be 180 plus 60 degrees. 63 degrees rather. So 180 plus 63 degrees is going to give me the grand total of 270. Am I making this up? 18 plus, you see I can't add, children. 243 degrees. I can add, I promise I can. So we have 243 degrees. Is that all right? Hopefully that's making sense. And so now we have this concept of arc length. We've dealt with arc measure, but now we've got the concept of arc length. And arc length is literally, as we talked about before, if I took a shoestring, or if remember my pizza, if I ate this piece of pizza and I left the crust, I want to know how long the crust is. But who leaves the crust of pizza? What kind of strange people is that? I don't know what that is. Okay, so that's a bad thing to do. Eat the crust, people. Eat the crust. Eat the arc length, right? So if I'm measuring the crust, I'm measuring the arc length. The arc length is going to be directly associated with the circumference. So it's the ratio of the length of the arc to the circumference is going to be the same as the degree measure of the arc to 360. Whoa, whoa, whoa. What are you talking about? Well, if you look at here, you've got the circumference, the arc length to the circumference is the same as the central angle, or the arc measure, to the total 360 degree. And if you solve for the arc length, which is this fancy L is equal to, what will we do on both sides? Multiply both sides by 2 pi r, or the circumference. Then we get circumference times x over 360, right? Remember the last video where I struggled to give you the formal definition of the arc length? I said it would be the circumference times the central angle over 360. Notice that this is really saying the same thing. Sorry for flipping through this so fast. The circumference times the central angle over 360. So we have the same thing. Cool? Cool. All right. So now that we've gotten through that, let's see if we can find the arc lengths that they give us in this case. So it says that the arc length formula is the circumference times the central angle over 360. And a better formula would be 2 pi r, which is the circumference, times central angle over 360. And so now that I have my formula down, let me use a dot for multiplication here. I'm going to literally just plug in the information. So if I'm looking for the arc length of zy in this case, then what I'm going to do is take 2 times pi times 4, which is the radius here, times the central angle, 75 degrees, over 360 degrees. And so this is basically calculator ready. So I'm going to go and move to my calculator and put all this information in so I can find that arc length. But quite honestly, before we get to doing the calculator version of the answer, let's give the exact answer. And exact answers use equal signs. So I can take 8 pi, which is the 2 times the 4, and times the pi, and then I'm going to multiply by this fraction here. What I would do with this fraction is reduce it as best as possible. To reduce the fraction, I need to look for what will go into 75 and 360, and hopefully you guys realize that I can divide 5 into both of those numbers. When I reduce that fraction and divide 5 into the top and bottom, I end up with 15 over 72. And so how I'd write this would be 8 pi times 15. I'm not done yet. I know it looks crazy. Over 72. And then I'd reduce it where I can. So since everything is being multiplied at the top and bottom, I'm going to reduce this because I know 8 goes into itself one time, but 8 goes into 72 9 times. And then I look at 15 and 9 and I realize that they have a common factor of 3. And this becomes 5 here and 3 down here. So my exact answer after all is said and done would be 5 pi, notice 5 times pi, over what's left down here, 3. 1 times 5 times pi, 3. So 5 5/3 pi would be the answer. The calculated answer that I would get, I would, plug all that into the calculator. Uh-oh, where did that go? I'd plug all that into the calculator and I'd get 5.23, and I'll just show that it's the same thing as 5 pi divided by 3. You get that same 5.23 after reducing. So if you were asked to give the exact answer, I want you to know that you can do that. But when you incorporate the calculator, that's when you get the approximate answer. 5.23 inches is what we're working on. Cool beans? All right, let's take a look at this next one. We're supposed to find zy here, but zy is a little bit different. The diameter is given as 10 centimeters, therefore the radius is going to be 5 centimeters. I'm going to put the formula, the preferred formula, which is the circumference times the x degree central angle over 360, and I'll give the exact answer like we did before. So 2 pi r, well really I could have used pi d for the circumference, right, since we've got that. So 2 pi r would be 2 times 5, so it's basically 10 pi. Are you guys with me? I hope that made sense. And then 130 over 360, and I can reduce by dividing both top and bottom by 10, and I think that's all the reduction I can do. I have therefore 130, 13 times 10 over pi over 360, and I can reduce out the over 36. I'm sorry, Chablitos. Let me try that again. So I divided top and bottom out of 10 out of top and bottom fraction just to reduce it, and that's as much as I can reduce this. I'm multiplying by the 10, so I get 130, but the 36 is still down at the bottom by itself. And now I realize, oh, okay, I can reduce this further, and that's how you would leave your exact answer, by reducing it as much as possible. So here I can divide top and bottom by 2. So when I do that, I get in the numerator I'm going to get 65, and in the denominator I'm going to get 18. And I think that's it in terms of reducing it as much as possible. So this would be the exact answer. The approximate answer I would get by going over to Desmos and taking 65/18 pi and figuring out what that is. And I'll just do it right here. So 65, oh no, not there. I'll do it right here. So 65 pi divided by 18. Notice I type in pi and then they give me the pi symbol, divided by 18, and I get 11.34, and that sounds pretty good to me. So it's equal to approximately 11.34 centimeters. You guys with me? So you see my approximate values for A and B. Let's go ahead and talk about C. So in C, they want me to find zy still. So you guys know the deal. It's going to be 2 pi r times the central angle over 360. And so 2 pi r is going to be 2 times pi times 6 times central angle 75 over 360. And I mean, you guys know how we're doing this, right? You see how this is going. And so just so I can be mathematically dexterous, since everything is being multiplied, I can literally just go, oh, I can cancel this way. So 6 goes into 360 60 times. So that 6 is gone. And then I can divide this by 2 later. I can divide this by 2 and say that 2 goes into itself one time, 2 goes into 60 30 times. And then I can say, oh, well, 3. I can divide these guys by 3 and I get 25 over 10. So I end up, and if I can do that, then I can divide it by 5. And so I get 5 and then 2. And then so I'm left with 5 pi over 2. That looked like some kind of witchcraft. I know you're like, what on earth happened there? Hopefully it kind of made sense though. I kind of just reduced everything out. Let's talk about what we could have done had we not done that. What we could have done is taken the 2 times 6, you get 12 pi times 75 over 360. And then you could reduce it just kind of any way you like. You know what I mean? Just looking for common factors. Do you want to see me reduce it again? Do you want to? I don't think you do, but I'm going to do it anyway. So when I divide 12 into 36, I get 3. So 12 into 360 is 30. So that 12 is gone. So I'm left with 75 pi over 30. And then I'm going to reduce that again, right? Because 3 goes into both of these. Actually, 15 goes into both of them. 15 goes into 75 5 times. And 15 goes into 30 2 times. So that's how we get that. I don't know if you wanted to see that, but I kind of felt like we needed to. So I can get the approximate answer by going to our friend Desmos or any calculator and taking 5 divided by 2 and multiplying all of that times pi, which is the same as 5 pi over 2, by the way. And I get 7.85, and that's the number I'm going to put down here as my answer. So my answer is approximately 7.85 inches for the length of that arc. Are you guys feeling super good about this? Okay, are you guys feeling marginally good about this? Are you okay? Are you satisfied? Okay, hopefully you're okay and you're satisfied and you're feeling okay. So let me know if there's anything that I can help you out with. I look forward to talking to you soon, and take care.